Let's graph our first interval. Let's look at the first example. We have -1 and 1. First step we need to take is we need to draw a number line because we're graphing. We write 0 here and let's write -1 on this side and let's write 1 on the right side. Now, we are dealing with brackets. Don't get confused. These are parentheses and these are brackets. And since we're dealing with brackets, what does that mean? It simply means that the end point, let's write a little note over here. The end point is included. So, whenever it's included, we have a closed a little circle like this, which represents it's closed. So we can close here and we can close here. It means that -1 and 1 is included. What does that mean? Let me quickly give you the definition of interval so that you can understand why we do this. So interval tells us that tells us the right here the set of numbers between 2 and points. So between -1, endpoint -1 and endpoint 1, the numbers -1 and 1 are included if we were to write a set. Let's move on to example number 2. Example number 2, we have -4 and 1. Let's graph this on the number line. Let's locate the origin and 1, 2, 3, 4 steps towards the left and 1 step here. Now, pay close attention. Here we have a parenthesis and here we have a bracket. Now, we talk about the brackets. What about the parenthesis? Well, it's the opposite, right? It means that let's write a little note over here. It's always important to write notes when you are learning math. The endpoint is not included and open it's an open point. So in this case we can draw a circle like this and here we can include a circle. So we will have here like this. Okay, now what does that mean? Remember the definition of an interval. It tells us the set of numbers between two endpoints. So if we were asked to write the set of numbers of these interval, well, 4 wouldn't be included, but 1 would be included in this set. Right, let's move on to problem number 3. Let's write it over here. And for number 3, we have this example, -4 and 1. So let's go ahead and let's draw a number line. We have the origin here, 0. Towards the left, -4. And towards the right, -1. Now, in this case, look, we have parentheses on both sides. So it means that -4 and -1 are not included. So if we were to write the set of this interval, -4 and -1 would not be included in the set. All right, I hope you're understanding. This is helping you. You can always let me know down in the comments. Your suggestions are very important. Your feedback is very important. Now, in this case here, this is very similar to problem number 1. So let's go ahead and let's graph it. But the origin is here, right? But in this case, we have 1 and we have 2, 3, 4 over here. And yes, it's included. If we were to write the set of this interval, 1 would be included and 4 will also be included. All right, let's go ahead and let's work on this one. This will start to get a little interesting with this problem over here. So first, let's graph and then we look at what is included and what is not included. So over here is the origin. So we're graphing on -1. So let's rewrite this. Over here is 0 and -1 is over here. Now, pay close attention. As you see here, that is a negative, right? But it's a positive, sorry, this is an infinity and it's a positive infinity. So we're moving towards the right. So we're moving from here, -1, all the way to infinity. But something interesting is that you should note this down. Note this, that infinity is, now we ask the question, can we include infinity? All right, let's look over here, right? We have -1, which will be included. But what about infinity? Since it's parentheses, are we including infinity? Well, that's a very interesting question because infinity is always written in parentheses. So infinity is always written in parentheses, and let's ask the question why. Let's answer why. Well, because, let me write a little note here. This is very important to write our notes. Infinity, because infinity is not an actual, it's not an actual number, right? So if we were to include infinity, what number would we be including? So there isn't an actual number you can include. So infinity will always be written with parentheses next to it. So if we were to graph this number, in this case, we were if we were to write the set of this interval, well, -1 would, yes, would be included, but infinity, well, we cannot find an actual number for infinity, so what should we include? Well, we can include, it will be like never-ending numbers that will be in this set. So yes, now let's move on to this other problem. We have problem, that was problem number 4, if not mistaken. 1, 2, 3, 4. This is 5. Now let's move to problem number 6. So problem number 6, 1, 2, 3, 4, 5, 6. We have this example, negative infinity and 0. So let's graph this. So 0 is the origin, right? So we're moving towards the left, and remember, always write it like this because it's negative infinity. So we basically would be moving from here all the way here to infinity. Now let's see what is included and what is not included. So absolutely correct, right? So infinity will always be written with parentheses, so we cannot include an actual number. But for the 0, is it included in the set of the interval? Yes, it's a closed, it's brackets. The endpoint is included. So yes, and there you have it. If you can practice these, it will build a strong foundation to move in graphing harder intervals in the future.